In this video, we're going to be talking about a laboratory procedure that we use to determine the concentration of an acid or base solution. If we don't know it, this is called titration. You are going to need your notebook, you're going to need something to write with, and once you have those ready, let's go. So a titration is, very simply put, a stoichiometry experiment. So we are still doing stoichiometry even at the end of the year. I told you guys it was never going away. Right? And the goal behind this is to figure out the concentration of an unknown acid or base solution. The way we're going to do this is we're going to react the acid and base very slowly until we hit what's called equivalence. Equivalence is the point where the reaction is completed. So you have the same number of moles of acid in your solution as you do base. Now, the pH at which this occurs depends on the salt solution, right? So if we form a basic salt, the equivalence point's pH will be above 7. If we form a neutral salt, it will be at 7. So that's the reason why we actually went through doing acid-base salt hydrolysis. In order to perform a titration, we're going to do it in a series of steps. Now, the equipment that we have down here may not be exactly the same as the equipment you're going to be using, but it's the same general process. What you do is your unknown substance, you take a very carefully measured amount of it, and you add it into a flask, and you dilute it with some water. The amount of water that you add doesn't matter. The reason why we're diluting it with water is just so the indicator that we add in a moment will be easier to read. Right, so we add a measured amount in, then we add in a couple of drops of indicator. So the indicator is a substance that's going to change color when our reaction is completed. We choose the indicator based on the type of salt that we're going to make. For example, if we're going to make a basic salt or a neutral salt, the indicator we generally use is phenolphthalein. It's colorless in acidic solution, pink in basic solution. In fact, for the titration we're going to do, that's the indicator you're going to use. Then you very slowly add your other substance in, 1 drop at a time while swirling. So add a drop, swirl it, add a drop, swirl it, add a drop, swirl it. And you keep doing that until the indicator changes color and remains that color for at least 30 seconds. So you'll know in your titration that it's going to be done because your solution will turn a very pale pink color, and when you swirl it, that pink color is going to stay there for at least half a minute before you add your next drop. And then what you do is you record the amount of solution that you've added, right? So we take its initial measurement, we take its final measurement, that tells us how much you've added. That's the process to do a titration. Now, the math is something that you've seen before. The equation, MAVA equals MBVB. Let's see, where does this look familiar? Oh, wait, that's right. It looks like the dilution equation, M1V1 equals M2V2. It also bears a passing resemblance to Boyle's law, right? P1V1 equals P2V2. So, same equation, same math. You can work with it as is, so we don't really need to go over how the math works. Just keep in mind that MA and MB are the molarities, so the concentrations. VA and VB are the volumes that you added to the reaction. And keep in mind, VA and VB, it doesn't matter whether you do milliliters or liters. As long as you're consistent on both sides, the math will work out. All right, so that is acid-base titration in a nutshell. We're going to be doing an example of this as one of our labs. And if you have any questions on this, we will see you guys in class.